Hey guys, another chapter 4 video here. This one is from section 4 in our textbook if you're in our class. And the essential question is, how can I describe and explain data? So in class we're kind of talking about real life data and how we can connect that with some of our algebra skills. And when we're studying real life data, real life numbers are messy. They don't often turn out to be in a perfectly straight linear line. But they can be close, and we can still use linear lines to describe the data if it is close. So we're going to get into our main topic today, which is this word, correlation. Correlation is just another way of saying describe data. In fact, if I was to give it a definition, it's a description of the strength of the relationship between two variables. So I'm going to say that again. It's a description of the strength of the relationship between two variables. So if you're comparing two different things, an x and a y, you get to talk about how closely are they actually related. Are they really, really alike? Do they have a strong relationship? Is it weak? Is it linear? I'm going to show you what that looks like. So if that's what correlation is, when do we use it? Well, we use it all the time, actually. We talk about the relationship between data all the time in math and in science. There's a lot of real-life examples, and I'm going to give you a few as we go through this video. So one of the things we like to talk about, well, two of the things we like to talk about with correlation is we like to talk about form and direction. And what I mean by form and direction is, form means, does the data actually look linear or is it non-linear? That means, does it look like a line or does it not look like a line? That's one of the things we often talk about when we talk about correlation. Direction means, does it look positive or negative when we start talking about slope? Does it have a positive slope or does it have a negative slope? So let me give you an example. I'm going to draw a graph, and for your notes you could sketch a little graph that looks similar to mine. My graph doesn't have any numbers. It's not a great graph. It has an x and a y axis and it has some kind of sporadic points on it. So you might pause the video and just kind of lightly sketch your own graph. But when I look at it, this is what I'm looking at. I'm looking at all those data points that are kind of sprinkled out on the graph, and I'm imagining if I was to draw a line through them, something like this. Notice my line is going in a negative direction. So when I look at the data, I'm like, well, it kind of looks linear. I know it's not a perfectly straight line. Like if I was to connect the points, they'd be all over the place. But it's kind of linear and it's definitely negative. So if I had to describe that correlation, my description would be, oh, it's negative linear correlation. That would be my descriptive words I could use. Negative linear correlation. Okay, so put your pencil down for a minute. You don't have to put this in your notes, but I'm going to show you some examples of some graphs. And I'm going to look at them and give them some describing words. So here's a graph that I would study. It has data on it. Again, not a great graph. It doesn't have any numbers, and there's no story here to tell you about what's the variables we're talking about. But just look at those data points. What do you notice? Hopefully you notice they're going in a downwards direction. So correlation-wise, it looks negative. But it really doesn't look linear. That line that I just drew doesn't really match the data. I'm going to take that line off. It looks more like this. It looks more like a curve. So in my quick look at this graph, my personal opinion, I'd say, well, it looks negative, but it looks non-linear. Doesn't look like a linear correlation. So negative and non-linear. Versus like this graph, if I drew a line on it, well, I could argue that it looks a little bit more linear. And it's going upwards with a positive slope. So I would argue that this has a positive linear correlation. So I'm going to write that down, positive linear correlation. Okay, so pick your pencil back up. And let's talk about one more thing we can write in our notes, and that is the strength of our graph. What is the strength of our correlation? Well, we kind of categorize into three categories. We go either it's a strong, moderate, or a weak correlation. And I'm going to show you what that looks like. So it's either strong, moderate, or weak. Here's a picture of a strong correlation. Maybe you want to draw like a real light sketch in your notes, but look at the line and the data points. Do you see how close those points are to the line? I mean, they're all pretty much touching the line. That is a really strong correlation. It's really, really linear and it's really close to that line. Here's an example of a moderate correlation. Same story, sporadic points, there's a line down the middle, but it's not as tight and close. You see how it's just moderate and not as strong? Here's an example of a weak correlation. Points are real spread out. I drew a line through them. It looks linear, but it's not super tight. So when I have to describe these three graphs, the first graph I would say is very strong. I would also say it's negative and it's linear. So I have three describing words. It's strong, negative, linear correlation. I would say the graph in the middle is moderate, negative, linear correlation. And then I would say the last graph is weak, positive, it's going up, positive linear correlation. I've got three descriptive words for each of these graphs, and that's how I want to do all of my correlation sentences. I want to use three descriptive words. So now let's look at some sort of example. Let's pull out some data. So here is the graph we're going to do for this example. In this graph, we're measuring two different things. On the x-axis, we have board length, and on the y-axis, we have time in seconds. And if I was to draw a line on this graph and try to describe the correlation, I would say it looks pretty dang strong. Look how close those points are to that line I drew. So it looks very strong, it looks linear, and it's going upwards in a positive direction. So I'm going to write my correlation sentence. I'm going to say there is a strong, positive, linear correlation, and then I'm going to say between board length and time. I'm going to describe my variables. So between board length and time, there's a strong, positive, linear correlation. Let's try another one. Next example is going to be about a different topic here. Have you ever seen one of these smart cars before? They're really small, lightweight. You can park them anywhere because they're so tiny. They're great for like driving in big cities and trying to find a parking spot. Versus like a car like this, one of those big old Hummers. Some people love smart cars and there's other people that totally hate them. They think they're ridiculous. And some people love Hummers, but there's other people that think they're ridiculous, and they have their good reasons. But there's something interesting about these cars. When you fill them up with gas, you fill up that little smart car with gas, and it's going to last a really long time. You can drive everywhere. You fill up the Hummer with gas, it doesn't last very long. You got to fill it back up again. So we call that fuel efficiency. How well does the car use its fuel? The smart car has great fuel efficiency, great miles per gallon. The Hummer, not so much. You're going to be spending a lot of money on gas for that Hummer. And we are going to look at a graph that compares the weight of cars to their fuel efficiency. And there's a whole bunch of data points on here. So a team of researchers has gone out and researched cars. They've weighed the cars and they've looked at how much miles per gallon they get. And so on the x-axis, they've got that weight of the car. And on the y-axis, they have that fuel efficiency. And what you should probably notice in the graph is that as you go out on the x-axis, you're getting cars that are heavier and heavier and heavier. So the farther out you go, it gets heavier. The farther down the y-axis you go, the worse the miles per gallon get. So your miles per gallon, your fuel efficiency is dropping and getting lower and lower and lower. So if you look at our data points, it looks like we have a line going in the negative direction. As it's getting heavier, the fuel efficiency is going down, which makes sense. The heavier the car, the worse the gas mileage. So if I had to describe this correlation, I would say it definitely looks linear. It definitely looks negative. But strength-wise, do you think it's strong, moderate, or weak? I'd probably go with moderate. It's pretty close to the line. So I'd say there is a moderate, negative, linear correlation. And then I would say between weight of the car and fuel efficiency. I'm going to include those variables. So there is a moderate, negative, linear correlation between the weight of the car and fuel efficiency. Notice how I'm writing my sentence. I'm going to write my correlation sentence kind of the same way every time. I'm going to use my three descriptive words, and I'm going to say between the x and the y variable, whatever it is on the graph. So in this case, between the weight of the car and fuel efficiency. Okay, let's try another one. How about this? Let's look at a graph that has two different things on it. On the bottom, it's got the age in years of people, how old they are. And on the y-axis, it has the number of pets. So somebody has gone out and done a survey. Maybe they're knocking on doors saying, "Hi, how old are you?" And they're writing it down. "And how many pets do you have?" "Oh, okay," and they're writing it down. And then they're graphing it. So all those little dots on the graph represent how old the person is and how many pets they have. And the question is there a correlation? What's the relationship? Can you draw a line through these data points? And honestly, if you look at it, the points are spread out and pretty random. I would say in this example, there is no correlation. The data looks non-linear. There appears to be no correlation between the age and the number of pets. And really, if you step back and think about that, that totally makes sense, because does your age really determine how many pets you have? Couldn't a 5-year-old have 2 dogs at home and a 50-year-old also have 2 dogs? Just because you're 75 years old, does that mean you're going to have a lot of pets? No, not really. Age doesn't determine if you're going to have pets or not. The pets is a personal thing, like either you like animals or you don't like animals. Either you want to have lots of dogs and cats and fish in your house or you don't. So there's no relationship, there's no correlation there. So the data is going to look nonlinear and there appears to be no correlation. Okay, one more thing for our notes here. Let's talk about an outlier. Do you know what an outlier is? An outlier is a random piece of data that doesn't fit the rest. So I'm going to write a piece of data that does not seem to fit the overall pattern. Sometimes researchers will go out and they'll do all their research and they'll collect all the data and it'll look super linear and all the points are going in a pattern. Except there'll be like this one data point that doesn't fit. That's an outlier. Here's a really good example. All the data looks like this nice curve going together, and then there's this random point over here that's an outlier. Outliers are going to happen. In real life, we have odd cases, and that odd case might not fit the rest of the trend. So we give it a name. We call it an outlier. Okay, guys, so just a quick summary overall here about correlation. When we're describing the correlation, we look for 3 things. We look for strength, direction, and form, and we use all 3 in a sentence. So we talk about, is it strong, moderate, or weak? We talk about, is it positive or negative? And we talk about, is it linear or non-linear? And sometimes there is no correlation at all, like age and pets, that example we did earlier about how old you are and how many pets you are. Sometimes you don't have a correlation at all. Hopefully you kind of followed some of this, and in class we're going to practice writing correlation sentences. Do not forget to include all 3 describing words, super important. All right, thanks guys, have a good day, bye.